So within the sequence, the output is dependent on previous elements or prior elements within the sequence. So recurrent neural networks are widely used in time series data, in natural language processing. So RNN widely used for time series data, NLP, like speech recognition, language translation, etc. So I have seen RNN, one type of RNN is also used in Siri. The Apple Siri also uses a type of RNN which is developed by Google itself, and Google Voice Search also uses a type of RNN which is developed by Google developers for their internal usages. So RNNs are recurrent neural networks are algorithms that use sequential data as input. Sequential data as input. So RNNs are widely used in natural language processing and time series data. Clear? So one of the popular RNN algorithm is LSTM, or also called as long short memory network. So this is a type of RNN only. LSTM algorithm is a type of recurrent neural network only, RNN, LSTM model or LSTM network. Okay, so an LSTM network is a model of your is a type of your RNN only. It's a type of recurrent neural network which is widely used in time series data and also used in natural language processing related tasks like speech recognition and translation, language translation, and all language translation type of work. Okay, so we will use this LSTM network in our class today. We will be looking at the LSTM network model in the session today. Okay, so if you are looking at how does this LSTM looks like, so this is a structure of LSTM network. This is a structure of LSTM network, which is widely used. And you can see there are a lot of formulas which are involved in this LSTM network, and predominantly the activation function which is used in LSTM network is sigmoid and tanh. The preferred activation functions are your sigmoid and tanh. Okay, now xt is your input vector, xt is your input vector. The input vector is xt. ht minus 1 is the previous cell output. ct minus 1 is the previous cell memory. ht is the current cell output, and ct is your current cell memory. Okay, and then you have two types of calculations: element wise multiplication and element wise addition. So once the data is given, you can see here ft. ft, the formula is sigmoid into xt into uf plus htm minus 1 into weight f. So forget gate. So f is your forget gate here. F, what you are seeing here, ft is your forget gate. Candidate is your C is your candidate gate, IP is the input gate, OP is the output gate, and weight and W and U are weight vectors for forget gate. So what happens is this algorithm has something called forget gate. The forget gate is for removing the observations which are not relevant to the, hello? Yeah. Your name, please? No, I have not checked it. I'm in a class right now. I'll check it and get back to you. Okay. You will get an email response. Did you email me? Acha, you are the international student, right? Okay. I'll send a mail. Just send me an email from your end. Okay. Hmm. So the forget gate is where features which are not required are eliminated. Okay, and those important features which are required in our calculations are propagated through the network. So it's a very complex calculation model where it uses the previous cells calculation as a memory, and also uses them in calculating the future data points. It also uses the calculation of future data points. So what LSTM has is the observations or elements are propagated through time and layers to maintain a constant error. So in LSTM network, errors are back propagated. Errors are back propagated through time and layers by maintaining a constant error rate. A constant error rate will be maintained, and only the errors will be propagated, not all the observations. The errors will be propagated. And LSTM also stores in memory. A short-term memory will be created in the network. It will store in the memory particularly the calculations, the inputs and outputs of the network. The inputs and the outputs of the network are stored in a memory, so that it can easily access them and use it for calculation through the layers and the gates. So this network stores the reliable information required for the future calculations based on the future inputs into a cell, which can be used for as and when it requires these calculations, it can bring back from the memory cell and then propagate them through the layers. If it finds similar set of what you call similar set of observations or similar set of patterns are being repeated, it brings down, it captures the memory calculations back to the network and uses them to calculate. And it uses the forget gate to remove the unnecessary what you call unnecessary observations or calculations, which does not help in what you call predicting the output. So that is the difference between normal RNN. In normal RNN, we will not see a forget gate, but here we have a forget gate that throws away the information which are not required for future calculations. So the algorithm will decide and retain those information which are required for future calculations. And the activation functions used are sigmoid and tanh. Sigmoid and tanh are the activation functions which are used in this LSTM model. Okay, any doubts till now? Shall I move forward, participants?
Sir, can you just scroll up?
Here.
Sir, what is element-wise addition and element-wise multiplications? Like,
Observations. Elements are nothing but your observations.
okay, okay, sir.
Elements are nothing but your observations. So forget gate removes information that is no longer useful in cell state. So forget gate removes the information which is no longer useful in cell state. Cells are different memory blocks. Cells are your different memory blocks in RNN. So cells means they are the memory blocks. Okay, and the input gate will do addition of useful information to the cells. So The input gate provides the useful information to the cells. Now, the input gates have activation function, the sigmoid. Activation function sigmoid filters the values to be stored in cell memory. So what are the values that should be stored in the cell memory will be decided by the sigmoid. Now, tan h function, tan h function, tan h activation function gives the output values from the cell. The output values are generated by tan h function. And the final output gate, extracts useful information from the current cells to be sent as output using the tan h function. Using the tan h function, the final output will be generated. The final output will be generated and it will be sent to the final output. So typically, a long short-term memory network has 4 neural networks. If you look at it here, the chain structure, the LSTM chain structure, the default one, contains 4 neural networks and different memory blocks. Different memory blocks are also called as cells. So this is the explanation of the diagram which is there in the top. The responsibility of the forget gate, the input gate, and what is the cells, memory, how each function is used to generate, and how each function has a role in the LSTM network model. This is the explanation of the LSTM network model. Any doubts, participants?
No, sir.
Okay, let us continue. Other guys, shall I move forward? Okay, guys, shall I move forward?
Yes, sir.
So I will show you how to build a LSTM network for predicting share prices. Today, we will use an LSTM network to predict the share prices. Now, from pandas underscore data reader import data. So let us download this nifty data. Data dot data reader in brackets double quotes inverted V NSEI comma source is Yahoo Finance comma start is equal to 2010 -01 -01. So I am downloading the nifty data from year 1st January 2020 from Yahoo Finance. Oh, what is happening? HTTP unable to read the URL. Okay. What happened? Yahoo Finance not working, Stack Overflow. It worked 2 months back. Why it is not working? When I ran, it worked. Did you guys also, are you guys getting the same error? Unable to read the URL. Remote data error. It worked in July. What happening now? It is not working. Guys, do you get the same error or I am the only person who is getting it?
Seems the same.
Says unable to read the URL. Okay. Data reader, I think they made a change here. Data reader dot. Yahoo. Okay. So from pandas underscore data, they have changed this command structure. So we will go with the changed command structure. So from pandas underscore import Yahoo Daily Reader. Okay. Nifty is equal to Yahoo Daily Reader BACN SN. We don't need to give the source, so we can delete the source. Start is this. Yes, we got the data. Nifty dot shape. TT dot frame Nifty dot shape. Data frame constructed not called properly. Symbols is equal to start, retry, adjust, return underscore index, chunk size. It should return a data frame. Why it is not returning a data frame? Got the data as pandas data reader. How to see the data then? Return index, data reader, close network sessions, get actions, chunk size, return index. Okay, we got the data reader from Yahoo Finance. Guys, did you get any solution? How to see the data? It is downloading as data frame, but head is not working. Okay, pdo dot get underscore data underscore Yahoo. We'll try this function. Unable to read URL. Last one only it worked. Now they have changed the structure. How do we overcome this data reader structures? Not reading the URL. Why it is causing us so much of problems? Uh, Anybody got any solution for this? Mhm. Okay, let's try Y Finance. I think is it there? Just try Y Finance, another library for Python finance. That will install. Install Y Finance. It's downloading. Yes. You install Y Finance and then we will go with Nifty. Nifty, NSEI, inverted V, starting from 2010 till 2021, 11. What was the date yesterday? 18. Yes. So all of you install Y Finance and we will download the data from Y Finance. Okay, guys, all of you got the data? Can you guys confirm? Pip install. Did you install Raghu Chinmay exclamation pip install Y Finance? Pip install Y Finance exclamation. After that only you will find the import function. Got it, all of you? Yes. Yeah, so once you got the data, we need to reset the index because the index is date. So df1 is equal to nifty dot reset underscore index, and then you will select the column called close price. Because close price is stationary, we will take close price as the single column of our data. So we will reset the index and we will take close price as our analysis point. All right, all of you got this? So we are selecting only the close price column. So df1 dot head. See, only the close price column data we are selecting. All right, participants, should I move forward? Okay, so we will start with our pre-processing. From sklearn dot pre-processing, import a min-max scaler. Pre-processing, import min-max scaler, which is your normalizing and min-max scaler. We'll import the min-max scaler. Scaler is equal to min-max scaler, null braces, df1 is equal to scaler dot fit underscore transform bracket np dot array df1 comma sorry df1 dot reshape -1 comma 1. So we have reshaped the data into like this. See, you have scaled the data and have reshaped the data into -1 comma 1.
Sir,
Hmm.
what is the meaning of reshape -1 to 1?
So in Python reshape, so if you are looking at what is our data size, meaning of -1 to 1, so -1 is used when you don't know the axis. 1 is your column. Because we have converted into NumPy array as -1. It simply means that it is an unknown dimension. And we want to NumPy to figure it out. So -1 means we don't know the dimension. So we are asking NumPy to find out. 1 means your column dimension. Clear?
Yes, sir.
Okay. Now we'll create our train data and test data. X underscore train is equal to, or let us say, train underscore size is equal to int length of df1 into 0.70. So we are taking 70% of the data. we are taking 70% of the data as trained data. Similarly, test underscore size is equal to len df1 minus train underscore size. So x underscore train comma x underscore test is equal to df1 square bracket 0 colon train underscore size comma colon comma df1 square bracket train underscore size colon length of df1 comma colon 1. Underscore train dot shape 2035 observations of one column x underscore test dot shape 873 observations of one column. Okay, all of you got it?
So what is a colon 1 in the last column?
Colon comma indicates column selection, comma colon indicates row selection. You remember I location?
Yes.
Dot I location colon comma indicates the what you call column selection. Comma colon indicates row selection.
Okay.
You remember the I location comment and initially when I told you how to select columns, df dot I log colon comma means it is column selection, comma colon is row selection.
But in the first thing we did not mention one.
Zero, now we are starting with 0, right?
Okay. Yes.
0 colon train size.
Okay.
All right, all of you are done till this point. Okay, now we have to reshape the data wherein we give the last 50 days or last 100 days data as input, and then it should create independent variables accordingly. Okay, so what we will do is we will create independent variables which are nothing but the last 50 days or last 100 days, whatever time step we give, it will take that time step and it will create independent variables accordingly. Okay, so we have to write a small function for that. def create underscore data set in bracket data set comma time underscore step is equal to 1 colon data x comma data y is equal to null square brackets comma null square brackets for I in range of length of data set minus time underscore step minus 1 colon A is equal to data set square bracket I colon I plus time underscore step comma 0 data x dot append a data y dot append data set square bracket I plus time underscore step comma 0 return np dot array open bracket data x comma np dot array data y. So we written a function where based on our time step, it will create the two data frames x and y, which we will be using for creating our train data set and a test data set with independent variable. With independent variable, we will get this data. But look at the indentation. I am pasting the code, but be careful with the indentation. Once of you, all of you make sure your indentation is correct. So the data, see, we are creating two data frames, data y and data x, based on the time step. So if you say time step is equal to 10, it will take 10 data points as A, and then it will append it to data x. And data y would be remaining data, what you call the time step plus I as your remaining y data set or data frame. I'll explain this code. Once we run the output, you will understand. So basically, we are trying to create independent variables based on the previous data points. Sequential data points, we are trying to create a variable. So let me see, time underscore step is equal to 50 x underscore train comma y underscore train is equal to create underscore data set, what we have given in the top, x underscore train, right? X underscore train comma time underscore step, time underscore step, x underscore test comma y underscore test is equal to create underscore data set x underscore test comma time step, sorry, time underscore step. Now x underscore train dot shape. So we have one row of 50 observations. We have one row of 50 observations. Similarly, x underscore test dot shape. We have one row of 50 observations. So similarly, we'll put it here only. Print, sorry. Print x underscore train dot shape, print y underscore train dot shape. So we have only one row of y and we have 50 columns of x. We have 50 columns of x. I think we have to reshape the data. It is in a different format than what we required. So we have to reshape the data into straight. So this 50 columns should become 50 rows and one column. So like that, we will create a data set. So what we are trying to do here is we are trying to use the time step as an input, and based on the length of the data set, and we are using the time step as input, and we are creating a new data frame. We are creating a new data frame based on this create data set function. So we are creating null data, data x and data y for I in range length of data set minus the time step minus 1. A is equal to data set square bracket I colon I plus time step. That means I starts from 1 colon 1 plus 50 comma 0 data append. It is we are appending into a data x and we are appending the remaining to the data y. So one row, one column, it will create like this. We need to reshape the data. Once we reshape the data, then we will get the correct data. So let us reshape the data. Then you will understand how, what exactly I mean. X underscore train is equal to x underscore dot train dot reshape x underscore train dot shape square bracket 0 comma underscore train dot shape square bracket 1. So here we know the structure of the data. So we are reshaping using the, we are not using -1 because we know the shape of the data. So we are reshaping the data using the rows and columns. Now x underscore train dot shape. See, you got one column, 1 comma 50 comma 1. So 50 inputs, you are getting it, and then it is a also converting it to a sequential parameter x underscore test is equal to x underscore test dot reshape x underscore test dot shape square bracket 0 comma x x underscore test dot shape square bracket 1 comma 1. So we are trying to create a sequential input of data. Okay, so this is what we mean by 1 comma 50 comma 50. So for making one prediction, we are taking 50 days as input. Input width is 50, output width is also 50, offset is equal to 50, and then label width is equal to 1. So that restructuring of the data has to be done like this. So to make a single prediction here, we are using single time step model. Okay, single time step model or the create data set function will create data in this format. Okay, input width is in this case 24 hours data, offset is 24 hours, and then label width is 1, total width is 58. So in our case, input width would be 50 and offset width would be 50, label width would be 1, total width would be 100. So we are trying to make a prediction for 1 day based on 50 days of input, offsetting the 50 days, and then total width is 100 days for us, label width is 1. So this is how we are restructuring the data. Got it? What does the code I have written mean is this. It will create a data frame like this. Input width, offset, and then label width. So here we have 48, we are predicting here for 48 hours. In our case, we are predicting for 1 day, next day, by using last 100 days as input. By using last 100 days and as input, we are predicting the future. So this is what the create data set function will do. So create data set is defining a window of what you call time step window for our prediction. It uses the previous sequential time periods data for prediction. Got it, all of you? All right, all of you got till this point? So we will define a LSTM model for this. We will define an LSTM model for this. Okay, what is the time now? 10:52. Okay, we'll take a break and then we'll come back and define the model. Okay. Okay, let's take a break and come back at 11:15. All right. So in the pre-session, we have reshaped the data in such a manner that it uses the previous 50 days values to predict the future value. Okay, so this what you call prediction window, or the window for what you call rolling window. In actual finance, we call it as rolling window. The previous number of observations you are taking as an input to predict the future observation, one future observation. So every time you predict for the next, it will scroll down one step downwards. So that is what the sequential forecasting is all about. We use the sequential forecasting in time series, and in NLP, what word should come after another word? Autofilling, speech translation, speech recognition, those places it is widely used. Okay, so let us start building our LSTM model. From keras.models, import sequential. Sequential is the model builder. From keras.layers, import dense and dropout. Dense and dropout. From keras.layers, import LSTM. So we are importing these functions which are required for predicting the things. What is happening here? No spelling mistake. Okay. Keras dot layers import LSTM. So these are the functions we require for building the network model. Okay, all of you got these functions. So sorry, Keras LSTM. Computer vision time series. We are looking at time series. For weather prediction, this is all right. All of you got this. Now we will build the model. Model is equal, or let us use this LSTM only. LSTM is equal to sequential null braces LSTM dot add 96 comma return underscore sequences is equal to true comma input underscore shape is equal to 50 comma 1. Oh, I forgot LSTM function here. That's why we are getting the error. LSTM 96, and then in the end we have 3 closure windows. Then LSTM dot add dropout is 20%, 0.2. LSTM dot add, we are adding one more layer, LSTM with 96 filter units, 96 units. Return return underscore sequences is equal to true. Return underscore sequences is equal to true. LSTM dot add, again we are dropout is 0.2. Then LSTM dot add LSTM 96 units comma return underscore sequences is equal to true. So we'll add a dropout, LSTM dot add dropout is 0.2. We will add one more LSTM layer, LSTM dot add LSTM, again 96 units, return underscore sequences is equal to true. LSTM dot add dropout is 0.2. Okay, 1, 2, 3, 4 sequences we have done. Okay, then 4-layer network, right? So we have built 4 LSTM layers. Then LSTM dot add dense. We are predicting one single value, and LSTM dot compile loss is equal to mean underscore squared underscore error comma optimizer is equal to Adams comma metrics is equal to square bracket single quote mean underscore squared underscore error. LSTM dot summary. So we have built a model with 2,60,065 weights. So I will post this content in the chat window, but be careful when you are looking at the indentation. What happened? Hey, did you get this? Now it came. Okay. LSTM dot fit x underscore comma y underscore train comma fox is equal to 10. Six steps only it completed. Huh? Right? How we convert this number to actual number? So we got this as the RMSE. We got this as RMSE. This is your root mean square error. So Taylor dot inverse transform this. Oh, shape error coming. Okay, expected a 2D array, got one-dimensional array. So we need to get the actual value here. What is the actual value of this? So all of you got the output?
Sir, scroll up, sir.
Scroll up. Huh? Okay. Here?
Yes, sir. Here. Okay, sir. Scroll down.
So we have to transform this data back to normal. Anybody got to find it on Google how to transform one single value? Taylor transform single value. How do I convert this value, min-max scale value? So this is actually a scaled value, min-max scale value. We have to transform it back to normal value. Then we will know the actual RMSE. So how to do it? Any ideas? Because inverse transform is not working on single value. It is expecting an array. So let us do prediction. Train predict is equal to Lstm dot predict in bracket x underscore train. Okay. Train predict is equal to scalar dot inverse transform underscore transform train predict. Expected greater than 2. Actually, what we got in train predict, let me check. Yeah, we got all the values, train predicted values. Dot inverse underscore transform train predict found array with dim 3 estimated expected greater than equal to 2. They are in array only, right? Type of predict. Mhm. Python numpy. Hmm. Okay, the last layer before dense layer must be set as false. So that's what I missed. Did I do it properly here? So for the last layer, remove this written under sequence is equal to true. For the last LSTM layer, written underscore sequence, you remove true. Yes, we got it. So 5421.4062 is it is predicting for the next one. So np.sqrt, np.mean in bracket y underscore. Okay, we have to open one more bracket. Y underscore train minus train predict start 2. So 5421 is the RMSE. We are predicting it. This question is a singular value. So we are having a problem here.
Sir, for most accurate RMS value 0.2 and 0.5, no?
What?
For most accurate RMS value will be between 0.2 to 0.5.
Who said that?
Sir, internet.
No. RMSE, there is no fixed range. It depends on the mathematical units.
Sir, error should be minimum, no?
No,
Loss
that's
function.
what- see, if your mathematical units in lakhs, your RMSE will be in thousands.
Oh, yes, sir. The root mean square it depend upon that's why I use root square na mean square error.
Uh,
In mean square error, we root the mean square and then we get a RMS value.
yeah.
So what is the difference between them, RMS and mean square error? Yeah.
Only the square root. Mean square error is a very large value. X minus mean square.
Yes, sir.
The size of the value is the difference.
Okay, sir.
Again, scalar dot inverse underscore transform y train, it says expected 2D array got 1D array instead. Reshape your data is using array dot reshape -1 1. So RMSE is 175. RMSE is 175. So it is predicting with a difference of 175 points. So we have predicted the original model RMSE is also we can do it. So 4695 we are getting on the model RMSE. Okay, participants, all of you got the LSTM model, long short-term memory model.
Sir, here both the RMS are varying.
That is model RMSE, na? That is model RMSE. Model has lot of values, right?
Yes, sir.
Whereas here prediction is a single value.
Yes, sir.
See, you are predicting on a singular value, and then at singular value, you will have lesser RMSE compared to the model values.
Yes, sir.
Got it?
Yes, sir. Sir, we predicted last 15 days data. So suppose we predicted after 2 days, what is the outcome on the price of the data? Then how can
Test
we
data is there.
proceed?
Now, I have not predicted on the test data as of. Test data we have, right?
Yes, sir. Test data is there.
You have predict on test data.
Okay.
LSTM.predict, test predict, and calculate the RMSE.
Yes, sir.
We have not done it on test data, right? Test data is 803 rows.
Yes, sir.
So predict it.
Yes, sir. Sir, in test data, I'm getting RMS value 5865.
Yeah, you will get 5865. Yes. So test predict is equal to LSTM dot predict x underscore test. Test predict is equal to scalar dot inverse transform test predict. So np dot sqrt so what we got in test predict? Got the final value of 6019. All right, all of you got this?
Yes, sir.
Okay, so as part of your DL assessment, I want all of you to build a convolution neural network on the data set called CFAR10. Now, in the normal MNIST data, we have 28 by 28 images. Here you have 32 by 32 images. So slight difference in the image shape. I want you to build, just like how we imported MNIST and all. You remember last time when we did the MNIST model, if you remember our MNIST notebook, where we have done the fashion MNIST and all, where we have imported the data from Keras data sets and built a convolution neural network. And then see here, X train, X test is equal to, instead of MNIST, you have to use CFAR10. You have to use CFAR10 as your data here. Now the CFAR10 is also same type of data like your MNIST, but the size of the data is 32 by 32, not 28 by 28. So I want all of you to build a convolution neural network on this data. Will you guys do it?
Yes, sir.
And submit it as assessment?
Yes, sir.
Yeah. Start working on CFAR10. Whatever we have done on MNIST, whatever we have done on MNIST digits, same thing you have to do on CFAR10. Like how to see the image and all these steps should be executed on CFAR10, minimization of the data, and then you build a convolution neural network. All right. All of you got this? Reference is your MNIST notebook. Start working on this CFAR10. Create a new notebook in Colab and activate your GPU also. All right. CFAR10. So DL assessment. Train a CNN model on CFAR10 dataset. Got it, all of you?
Got it, sir.
Yeah, start working.